Let us address an important concept in computer science, something called as user mode and kernel mode. Think about how any well-managed system works, whether it is a university, a government office, or even a housing society in Pune. There are different levels of access defined for different peoples. Everyone does not get the keys to everything. And computers do also follow the same philosophy. User mode and kernel mode are two carefully designed working areas inside a computer. They exist not to complicate things, but to make sure that the system stays safe, stable, and smooth, even when many things are happening at the same time. Imagine a large administrative building at SPPU campus, Savitribai Phule University campus. Students, visitors, and staff move freely in open areas like lobby, classrooms, meeting halls. They can work, talk, study, and submit the forms. And this open area represents the user mode. Now think about restricted areas like the university data center, probably a server room, examination control room, power supply room, even like confidential record section. Only authorized employees or officers are allowed to be there. And this restricted area represents the kernel mode. The idea is not to stop people from working, but the idea is to ensure that the critical systems are not disturbed accidentally. If someone presses a wrong switch in the power room, the entire building can go dark. And the computers do follow the same logic. User mode is where almost all daily applications live. When a when a student opens a browser to check exam results, types an assignment in a document editor, watches a video, or even plays a game in the hostel, all these programs run in user mode. Applications have their limited access. They cannot touch hardware, they cannot change system settings, and these restrictions keep the system protected. And user mode, also known as a safe place. If one application crashes, the damage stays limited. For example, if a browser hangs while submitting an online Maharashtra government form or even an examination form in SPPU, the entire computer does not stop working. Other applications continue normally. So think of the user mode like a playground with safety fences. You can run, play, explore, but the fences ensure no serious accident happens. Kernel mode is where the real power lives. Here, the operating system has the complete control over the computer. It can access all memory areas, talk directly to hardware, manage files, control keyboards and mouse, and handle networking and decide how resources are shared. So when multiple students in a computer lab print documents in the same time or at the same time, kernel mode ensures that everyone gets fair turn. When Wi-Fi data arrives, when a pen drive is inserted, when the screen refreshes, kernel mode coordinates everything. Only trusted parts of the operating systems are allowed to be in kernel area or kernel mode. Giving this level of access to normal applications would be dangerous. So kernel mode is like holding the master keys of the entire building. Very powerful, but used with extreme care. Now imagine a simple action like saving a photo. A student edits a photo for a college event poster. The photo editor wants to save the file on the disk. The application itself cannot touch the hard drive directly. So what it does? It politely makes a system call. This is like submitting a request from a government office. The operating system temporarily switches into kernel mode, safely writes the data to the disk and checks permissions, updates file records, and completes the tasks. Once done, control is handed back to the user mode and the application continues smoothly. And this switching happens thousands of times every second, so fast that users never notice. It feels like a quiet helper doing all risky work behind the scenes. Now, why do the systems need both modes? This separation exists for a very practical reason. First reason is it prevents crashes. If one faulty application misbehaves, it does not bring down the entire system. Without this separation, a buggy game or an app would freeze everything and can result to the data loss. Second, it protects the data. One application cannot read or overwrite data belonging to another. So banking information stays separate from the browser. Exam data safe from casual access. Third, it keeps the system steady. When many applications wants the printer, network, or screen at the same time, the operating system remains in control and avoids conflict. And this design is the reason modern computers remain usable even under a heavy load. Consider that you are printing an assignment in the lab. So you click print inside your document editor. This click happens in user mode. The application prepares the document but cannot talk to the printer directly. So a system call is made. The operating system switches to the kernel mode. It checks the printer availability, manages the print queue, and sends command to the printer hardware and monitors the progress. Once the printing starts, control returns to the user mode. And now your application shows confirmation message and you continue working. So behind the scene, user mode and kernel mode quietly coordinating to make this printing appear simple. So user mode and kernel mode always work together. User mode provides a protected space where every applications run safely. Kernel mode gives the operating system full authority to manage the system. And this separation prevents crashes, protects the data, and blocks harmful programs from taking the control. The computer switches between these two modes countlessly or countless number of times every second without any visible delay. And this invisible coordination is what keeps your laptops, desktops, servers, and even government data centers running smoothly every day. So when you look at the computer today, it feels simple on the outside. You click, type, scroll, print, and everything just works. But the beneath this simplicity lies a very disciplined and thoughtful design. User mode and kernel mode together act like a well-run university or a well-governed Maharashtra government office. Everyone is allowed to work freely where they should, and only trusted authorities handle the official responsibilities. And this balance between freedom and control is what gives the computers their stability, safety, and reliability. And because of this separation, mistakes remain small, data stays protected, and the system continues to run smoothly. Even when many things happen at once, the constant switching between these two modes happens silently without disturbing the user, and yet it protects every click, every file, and every task. So, understanding these concepts is not just about learning an operating system topic or computer organization topic. It helps you to appreciate why modern computers are dependable, why crashes are rare, and why security is possible. And this invisible teamwork between user mode and kernel mode is the one which is strongest foundation of computer systems or modern computing. Thank you.